Hey guys, welcome back to our channel Geeks Practice. In this video, we are going to discuss how selection sort works, and we are also going to see how to implement selection sort in Java. Now, in this slide, you can see two arrays. One is unsorted array and the other is sorted array. We are supposed to sort this unsorted array in the ascending order using selection sort. We'll also see how to do this. First, let's understand what is selection sort. Selection sort is a simple comparison-based sorting algorithm, and it is divided into two parts. One is sorted and the other is unsorted. Sorted will be on the left side, unsorted will be on the right side. Here, this algorithm repeatedly selects the minimum element in the unsorted part of the array and swaps it with the beginning of the unsorted portion. After swapping, that element will become into the sorted position. So, this process is repeated until all elements in the array are sorted. This is how selection sort works. If you didn't understand, don't worry, we are going to check out the example. Here, we have this unsorted array and we are going to traverse with the entire array. So, the index is at 0, that is element 38. We are supposed to swap element 38 with the minimum element. The minimum element here is 6. So swap is 6 and 38. Now 6 and 38 are swapped. You can see I am mentioning orange color for the sorted part of the array and white color to the unsorted part of the array. 6 is shifted to the sorted part. Now in the unsorted part of the array, the first element is 52 and we are supposed to swap it with the minimum element. Here you can see 9 is the minimum element. Swapping 52 and 9. Once 9 is swapped into its position, 6 and 9 becomes into the sorted part of the array. From 52 to 47 is the unsorted part of the array. Now, the first element in the unsorted part of the array, that is 52, we are supposed to swap with the minimum element. The minimum element out of this 4 is 18. Now, swapping 52 with 18. Now, 18 is swapped and 18 is shifted to the sorted part of the array. Now, 52, 38 and 47 are the part of unsorted array. Now swapping with 52 with the minimum element, that is 38. 38 is shifted to the sorted part of the array. We are left with two elements, one is 52 and 47. 47 is the minimum element, that's why we shift 47 to the left side. After that 52 comes to the right side. Now all elements in this array is sorted in the ascending order. This is how selection sort works. Now let's see how to code this. Here in the main function, we are creating an array with the elements 38, 52, 9, 18, 6, 47. Now, we are passing this array into the function name selection sort, which is written above the main function. Once we get result from the selection sort function, we will run a loop, run a for loop and print the array, sorted array. Now, look into the selection sort function. Here in the selection sort function, we are passing the array that we have created and we are creating a variable n with the length of the given array. So variable n stores the length of the given array. This is used for looping. You can see a nested loop is there, which means a loop inside another loop. The outer loop here runs from index 0 to n-1 to traverse the entire array. The variable I represents the index of the leftmost element of the unsorted part. You already know there are two parts. One is sorted, which is on the left side, unsorted on the right side. In the right side part, the leftmost element, which means the first element of the unsorted part. So I here represent the first element of the unsorted part. Here inside the outer loop, you can see we have created a variable named minIndex to keep track of the index of the minimum element found in the unsorted part. Now considering the inner loop. The inner loop runs from index I plus 1 to n to find the index of minimum element in the unsorted part. So what is this loop doing? This loop is finding the minimum element in the unsorted part. Once we find the minimum element, we are swapping. We are swapping the minimum element with the first element of the unsorted part. How are we swapping it? We are swapping it using a temporary variable. We store the minimum index there and then we swap. So this is how selection sort works. And here this loops, the outer loops continues and in each iteration It reduces its size of the unsorted path one step in every iteration. We're sorting one element in every iteration, right? So the unsorted part of the array becomes small, one element less in every iteration. Now, speaking about time and space complexity. The time complexity is O of n square. How? The outer loop will run n minus 1 times. What about the inner loop? The inner loop is the size of unsorted array. Starting it will be n minus 1. After that it will be n minus 2. So slowly we will decrease the size of unsorted array. So slowly inner loop also decreases. So in total it is n minus 1 into n divided by 2, that is equals O of n square. Speaking about space complexity, we are not using any extra space. We're just creating a small variables, and that's why the space complexity of this selection sort is constant, that is O of 1. This sorting is performed in place, meaning it does not require additional data structures proportional to this input size zone. That's why the space complexity is constant. I hope you understand this video. If you like this video, please like it, comment it, share it with your friends. Thank you so much for watching till the end. Bye bye.